In this video, we are going to learn how to solve a right triangle. Now, what does it mean to solve a triangle? It's not necessarily an equation. So, by definition, to solve a right triangle means to find the missing lengths of its sides and the measurements of its angles. So we're going to find all the information we can about a triangle, and that's what it means to solve it. Now, luckily, since we know the right triangles, we're always given one angle for sure. It's finding the other two angles and the other three sides is what solving the triangle is about. So, using the right triangle shown on the left, this as a template, then using the given information, solve that triangle. So I'm saying here that A is equal to 2. So I'll put the information I'm given in green. So A is 2, so that side's 2. And then angle B, this is his upper angle, which is 40 degrees. So now that I know that, I'm going to find all the other missing parts of the triangle. Now the easiest one to find is A, because I talked about in the previous lesson that A and B are complements, so they should add up to 90. So if angle B is 40, then angle A should be equal to 50 degrees by subtracting 40. And again, 50 and 40 are complementary angles. Now, why am I putting this in a different color? Just because I usually, as I go to find the remaining sides, B and C, I don't want to use information I found in a previous step if I can. So I'll try to stick to just using these two bits of green information to find the other sides. So I still want to find side B and side C, what they're equal to. So using this given angle of 40 and that side of 2, I can see here that given that angle, I'm given the adjacent side. So I can use that to find the other values. So if I know that this is the adjacent side, cosine I know is adjacent over hypotenuse. So I can write this as 2 over C. And then I can go and solve this equation for C. So first I would multiply each side of my equation by C, giving me cosine of 40 degrees times C is equal to 2. And I could divide each side of my equation by cosine of 40, giving me C is equal to 2 divided by cosine of 40 degrees. Now, cosine of 40 degrees isn't a known angle on the unit circle. So we're going to have to use a calculator to find its value. And since I'm using degrees here, when I turn on my calculator, I need to make sure that I have it in degree mode. So now I'm going to type in 2 divided by cosine of 40 degrees. And I'll get that side C is about 2.61 in length. I even put 3 decimal places, 2.611. Now, so now I found side C. I found angle A, but now I want to find side B. So I know that if I'm going to use this 40 degrees again, I have opposite and adjacent. So opposite and adjacent, that's a good tangent. Again, I want to use that adjacent side since it was given to me. So tangent of 40 degrees should be equal to opposites, which is B, over adjacent, which is 2. So solving this equation for B, I would multiply each side of my equation by 2, giving me B is equal to 2 tangent of 40 degrees. So 2 times tangent of 40 degrees gives me B is equal to 1.678. And now you'll see here I know all of the angles and all of the sides. Now let's look at another example. So I know two of the sides this time. So I know side A, which is 2, and side B, which is 3. So now the first easier thing to get is to find what the hypotenuse is. Since I have the Pythagorean theorem, I can find that c squared is equal to a squared plus b squared. So 2 squared plus 3 squared, giving me c squared is equal to 4 plus 9, which is 13, making c equal to the square root of 13. But now I want to find angle B and angle A. So to find these, I'm going to need to use an inverse trig formula. Because now, for example, if I start with angle A, I can say that the tangent of A is equal to the opposite side over the adjacent side. Because I know opposite and adjacent from angle A, and then I can use inverse tangents and say that A is equal to arctangent or tangent inverse of 2/3. Now give me an angle for my problem. So tangent inverse of 2 divided by 3, 33.69. So A is equal to 33.69 degrees. Now I have to find the other angle. Now it's very tempting just to use the complementary angle fact that they should add up to 90, but we're going to use the inverse tangent again to find the other angle. This is usually just to be safe. So now we have tangent of B should be equal to 3 over 2, opposite over adjacent. And the reason why I'm using tangent and not cotangent of B for equal to 2/3 because I don't have a cotangent button on my calculator. So that would be very difficult. So now we can see that B is equal to tangent inverse of 3/2, giving me 56.31. And if I were to add these two angles together, it should give me 90 degrees. The only time you wouldn't see that happen is if like there's just a rounding change, like it was at the 0.5 mark, so they both rounded up or they both rounded down. That's the only time you wouldn't see that add up to 90, but it would be very close. So there's my side C, my angle A, and my angle B being 56.31. And I have solved that triangle as well. And that is how you solve a right triangle.